Okay, so we're going to start talking about data frames now. Remember, we've looked at the basic objects, which are vectors, matrices, arrays, and then also talked about lists, which is a even more broad generalization of that most basic type of object in R. And now we're going to talk a little bit more about data frames, which is more alike what we typically think of as data sets. We're going to talk about how to import and export and how to sort and reshape and do all the data processing that we so often need to do. Okay, so a data set is a data frame. That's just the name that R uses. It's matrix-like and can be thought of much as a matrix. And so similar to the matrices that we looked at previously, we can replace or select particular elements of a data frame using that square bracket notation or the $sign to get at particular variables, which would be columns, or rows, which would be observations. So for example, let's say we have a data set that is just a built-in R data set, has some state information, okay? So the first thing we're going to do is convert this over to a data frame. So you run it through the function data frame, and you save it in an object data. We can look at the first few observations, the first 6 or so, the tailing 6. We can look at the column names. We can look for row names as well. We can look at the dimension of that. Go ahead and run all of these and make sure this works. This is already installed in your version of R, so you should be able to obtain this with no problem. Once you're done running that, go ahead and try to select the variables or columns, population and income. You can do it this way. You could also get it by individually selecting or using the number of the population and income, which column it is in. Of course, then you need to go and look and see which of, in which order these variable names occur in your data set. We can obtain the area this way. We can get the first 5 rows, so this would be the first 5 observations. So, review of the vector. So remember how we emphasized how to understand vectors and matrices, and that's because this really transfers quite directly. So if we want to get data directly from the keyboard, as in typing it in, we just need to use the scan function. So this is a way that's very low level, but might be useful in certain settings. When you run the scan function, all you have to do is assign that scan function to an object. You can call that object anything you want here. It just happens to be called X. And then you just press enter twice, or press enter each time you enter a number and twice to stop entering the data. You can paste multiple numbers at each prompt and can also be used to import data sets. So notice you enter 4, enter 6, enter 10, enter 11, enter, and then X contains that column vector. I prefer to use read.table or read.csv. Read.table is going to read in any kind of delimited file. It could also read in a comma-separated file. Read.csv is specialized for comma-separated files and often does a little bit better and with less code than read.table, but you can really use either. The SAS files export the same way as tab delimited or CSV, and I always recommend keeping it in the most simple form. So if I'm going to export something where I know somebody's going to want to open it in Excel, I just export it as a CSV file, pretty much no matter what statistical programming language I'm using. So here's a summary of our functions for importing data. Read.table reads it in data format and saves it as a data frame. This is basically the same as read.table. It's just specialized for comma-separated files. And then we could read in data with fixed formatted data. This is not going to be delimited, but you have to specify the width of each of your fields. that's a specialized case that we may or may not get to. Okay, so here's the commands for read table. First, you put in your file, the name of the file that you want to import, whether or not it has a header, true or false. What is separating it? Is it space? Is it comma? Or what? Tab delimited is that symbol there. All right, so by default, anything that's going to be a character string variable is going to be changed over to a factor, which almost always is correct. You can adjust for other things in read.table, but this is most often the kinds of things you need to edit as a command. Okay, so the default separator is a space. Column names cannot have spaces if you use that, so you need to be very careful about using space delimiters. Character data also cannot have spaces if you do this. So there can be some issues that arise if you only use a space delimiter, which is why often tab delimited or comma delimited data is preferred. Missing data that's character valued needs to be specifically included as an NA, and this can be pretty tricky to include in particularly the character string observations or variables. So in general, CSV files are the preferred formatting. There's less problems with this. You can direct it to a particular file path. I like to set my working directory, but we'll look at how to do that later. Okay, so let's look at an example. Here we're reading in a CSV file. It has a header. The separator is, of course, a comma, and we're going to skip the first 7 observations and read and store it in an object data. So then we're going to get the structure of the data when we do this. Go ahead after this, I'm going to provide this example CSV to you, and go ahead and make sure that you can read this in and have some results here. Be able to see the structure of the data in particular.